Good morning, students. Good evening, students. And we discuss. Will discuss about the hydrogen atom. Uh, Only the phi equation we define. We will teach the theta and the radial equations. This is the phi equation that we already know. Dou square z by dou phi square minus m square z. Dou square z by dou phi square plus m square z is equal to 0. This is the phi equation. Similarly, also we have to find theta equation. Another is a radial wave equation. So in this theta equation, what we do? Now we separate theta and r, just like in the Ricci rotator. What we do in this theta and r equation, the left hand side is only of theta and r equation. What we do? Now we have to, here you see that everything is r. Here is the sine square theta. So what we do? Now we divide this left hand side by sine square theta. Well, what happens? Now this is removed. Sine square theta is removed. 1 by r dou by r, this will come. Here y sine theta will come. Here sine square theta is removed. So this one and this one becomes r. And this one is theta, and whatever we divide here sine square theta, this is the theta. This theta is one side, r is another side. Then we get theta and r equation separately. So we do one by one. So what we do? Now we have to make copy of it. This one, I make the copy of the left hand side of this one. I will make the copy of it. Sine square theta by r. I write here sine square theta. I write here sine square theta. Sine square theta by r, then dou by dou r, dou by dou r, r square dou r by dou r, r square dou r by dou r, plus sine theta by y, sine theta by y, sine theta dou y by dou theta, whole of sine theta dou y by dou theta, 8 pi r square mu by h r square plus 8 pi r square mu by h r square, E minus VR, E minus VR, r square sine square theta, r square sine square theta, bracket n. I write here r square sine square theta. I take it as m square. Both left hand side and right hand side we take as m square. So what we do? We divide sine square theta throughout the equation. Dividing sine square theta in the above equation, dividing the sine square theta in the above equation, if we divide sine square theta, this will move away. Then what is remaining? 1 by r dou by dou r, r square dou r by dou r, plus if we divide the sine theta, one sine theta is cancelled, then what is remaining? Y Sin theta is remaining in the bracket sin theta dou y by dou theta. Here we divide sin square theta, so this will be cancelled. We get what? Plus 8 pi r square mu by h r square. R square I take this side, r square bracket e minus vr bracket m. We get m r square by sin square theta. We divide both sides by the sin square theta. This is the equation. Here you see, this is the function of r, this is also the function of r, and this one is the function of theta, and this one also function of theta. You keep r in one side, take theta to that side. Okay, then what we get? 1 by r dou by dou r square dou r by dou r bracket n plus I take this one 8 pi r square mu by h r square r square bracket e minus vr bracket n 8 pi r square mu by h r square r square minus. We take this one to that side. To that side is remaining m r square by sin square theta. It is remaining. When we come to this side, it becomes minus 1 by y sin theta dou y by dou theta. Here you see, the left hand side is a function of r and the right hand side is a function of theta. So what we get, if the two are equal, then it must equal to a constant. Suppose I make these two are constant with beta. We take the constant, left hand side is equal to beta, right hand side is equal to beta. If the two are equal on both sides. If the two are equal in both sides, we keep both sides as a constant. If this one is equal to beta, this one is equal to beta, then we tell that these two are the equal. Then what we do? Now I take first the theta equation. We have to derive theta equation. What is the theta? Is m r square sin square theta minus 1 by y sin theta dou y by dou theta is equal to beta. Here you see, here is y and theta. Y is a function of theta, but here is y is remaining. Then what we want? Now we have to remove this y. This y we have to remove because both theta and y is present. Though y is a function of theta, no problem. But in order to make its separation very clearly, we have to remove y from this position. Then what we do? Now we have to multiply both sides by y. Here we multiply y, in this the left hand side also multiply by y. So both sides is multiplied by y. Multiplied by y. Both sides we have to multiply by y. Then what happens? Now here we multiply the y. Here is the y means y is remaining m r square y by sin square theta minus when you multiply y, this y cancel, we get 1 sin theta dou y by dou theta. Here we multiply y, both sides we have to multiply y. Then what we do? We take this beta y to this side and multiply minus in all cases. That means you take this one to the left hand side minus 1 by sin theta sin theta dou y by dou theta bracket n plus m square y by sin square theta, take this one to this side, minus beta y is equal to 0. Then what we do? Take y common and multiply minus all cases. When we multiply minus, it becomes plus multiplying minus. Multiplying minus on both sides. Multiplying minus on both sides. We have to multiply minus on both sides. So what happens? Minus it becomes plus 1 by sin theta dou y by dou theta plus, take y common, plus no, it becomes minus. This one is minus this one, that means m square, and this one becomes plus. So I take y common from both cases. Then what do we do here? We take plus, this one becomes plus, this one becomes minus, because we multiply minus, this one becomes plus. So we make bracket, because we take y common from that side. Here I write beta, because it is beta, here is minus m square sin square theta y is equal to 0. This is called theta equation. It is theta equation. Okay. Similarly, we have to find out radial wave equation. This is the theta equation. We already find out phi equation. Next is r equation. R equation means this one. We have to find out this radial wave equation. I have to write this one. This one is equal to beta. Then 1 by r dou by dou r square dou r by dou r bracket n plus 8 pi square mu by h square r square bracket e minus vr bracket n, here is common, okay, is equal to beta. Then what do we do? Now we have to divide r by capital R by small r square on both sides. On both sides we have to divide the above equation. The above equation is divided by multiplied by capital R by r square. Why? Now here is capital R, but all our variable is small r. So we have to remove this one. So we have to multiply with r. Then here you see that here is small r square. That means when we divide this r square, because here there is no variable. Here there is no variable. So it is not required, because r is a variable. So this is not variable here. So we have to remove this one. We have to remove this one, because all variables are small r. It is capital R, so it is not required. So we have to remove. Here small r, there is no variable. So we have to remove this one. So r by r square. If we multiply by r square, this r is cancelled. Then what is remaining? Now 1 by r square. Dou by dou r. What is remaining? R square dou r by dou r plus 8 pi square mu by h square r by r square. R square cancel. What is remaining? Capital R. capital R bracket E minus VR bracket N is equal to beta, both sides we have to multiply by R square. Take this one to the inside this left hand side. So then what happens? Now it is remaining as such 1 by R square dou by dou R square dou R by dou R bracket N. We take this one to this side, 8 pi r square mu by h r square R bracket E minus VR bracket N, this one to the left hand side, minus beta R by R square is equal to 0. From these two you take capital R common, or you can keep it like this. If you take capital R common, this will come to this one, okay, or you keep like this. So this equation is called as radial wave equation. It is called as radial wave equation. So we get all the three equations. We get phi equation, we also get theta equation, we also get radial wave equation. Now second question is we have to find out the solution of this equation. The phi equation, we have to find out the solution of phi equation. We have to take the solution of the phi equation. What is the solution? What is the phi equation? Now phi equation is dou r square z by dou phi r square z by dou phi r square plus m r square z plus m r square z is equal to 0. This is the phi equation. We have to find out what is the solution of this equation. What is the solution of this equation? How to find out? Now we have to do, we already know this one. We know that we have to take z phi. This is a second order differential equation. The solution is b e to the power plus minus I m phi. We already did this one in the rigid rotator. We also derive in this way. We already did this one in the rigid rotator. We also did in this way, because we want to find out this value, b value. Then we have to find out the normalization equation. Integration 0 to 2 pi. What happens? Now z phi asterisk d phi is equal to 1. Then we have to put this one 0 to 2 pi. In place of z phi I write b e to the power plus I m phi. Then asterisk of z phi, it is a complex conjugate number, so sign this plus sign should be converted to the minus sign, because sign only, if it is minus, then z phi becomes plus, okay, because it is the complex conjugate. So the z phi asterisk is b, whatever the sign here, asterisk means sign will change if the imaginary number is there. Here it is imaginary number, e to the power minus I m phi. D phi is equal to 1. Okay, this b square comes outside, b square, then what is remaining? E to the power I m phi, it is positive, into e to the power minus I m phi d phi is equal to 1. E to the power x, e to the power minus s, plus s minus x cancel, 0, something to the e to the power 0 is equal to 1. All are 0 to 2 pi, 0 to 2 pi, so it becomes 1. So what we get? Now b square is equal to integration 0 to 2 pi d phi is equal to 1. So integration of d phi is equal to phi. B square phi 0 to 2 pi is equal to 1. That means b square upper limit first 2 pi minus 0 is equal to 1. So b square is equal to 1 by 2 pi. 2 pi minus 0 is equal to 2 pi. That means b square 2 pi is equal to 1. B square is equal to 1 by 2 pi. Then b is equal to, then b is equal to 1 by 2 pi, the root over I already this in easy rotator. Then what is the solution of this equation? Now z phi is equal to b e to the power plus minus I m phi, that we already take. Then what is the solution? The solution is z phi is equal to, in place of b I write 1 by 2 pi the square root e to the power plus minus I m phi. This is called solution of phi equation. Similar also we find out solution of theta equation. We also already derived this one, theta equation. We already derived this one in the rotator. Again I will derive it. Then what we do? Solution of theta equation. In this case we know that integration minus 1 to plus 1 pk m x pl m x Legendre equation is equal to 0 when k is not equal to L. When k is not equal to L, it is equal to 0. Orthogonality function. This one is called as the Legendre equation. Then what happens? Now another equation is when k is equal to L, minus 1 to 1 p k m x p l m x dx is equal to 2 divided by 2l plus 1 l plus m factorial divided by l minus m factorial when k is equal to L. In this condition the equation is this one. So what is the solution? Y theta is equal to a p pl mx, x is equal to cos theta, a pl m x is equal to cos theta, this one. Then I want to find out this value of a. So what we do now, we have to find out normalized equation. Y theta asterisk d theta. You can take here x, in place of we write here theta. D theta is equal to 1. Normalized equation. We have to put this value. Integration y theta is equal to a pl m x x is equal to theta. If I take x is equal to theta, y asterisk, there is no complex conjugate, so there is no sign change. It remains same. PL mx is equal to dx is equal to 1. I write what? Now x is equal to theta. Then what happens? Now dx is equal to d theta. In place of d theta, I write dx and x is equal to theta. This is a, this is a. Becomes a square. I take outside, it is a constant. Then what is happen? PL mx dx is equal to 1. This one, this value is same as this value, because in place of k I write L, because k is equal to L. In place of k, if I write L, this one is equal to this one. Then what is the value? Now this value we have to put here. Then a square, in place of this we write this value, 2 by 2L plus 1 L plus m factorial divided L minus m factorial is equal to 1. Take this one to this side. Then a square is equal to 1 by 2 divided by 2L plus 1 L plus m factorial divided L minus m factorial. This will come upper one, go numerator. Then a square is equal to 2L plus 1 L minus m factorial divided by 2L plus m factorial. Then what is a? Now a is equal to square root of 2L plus 1 L minus m factorial by 2L plus m factorial. Then what is my equation? Y theta is equal to APL cos theta. So y theta is equal to A PL m cos theta. So in place of A, I write this value. So y theta is equal to square root 2L plus 1 divided by 2 L minus m factorial divided by L plus m factorial. This is A. Then PL m cos theta. This is called the solution of theta equation. This is the solution of theta equation. We already derived this one. Solution of theta equation. We already derived in the rotator. So same process we have to do. Then another is solution of radial wave equation. Here we do same process we have to carry out, but in this case it is not difficult. We do not take any, because in radial wave equation there is no theta, no phi, only r. R is a function of r, it is a distance, that is no angle. So it is very easy for derive the radial equation. So time is already there, half an hour, we end here. Hek terika re, konta kuadu asi pohଞ୍ଚିଲୁଛୁ? Hek ja, ଏ କୁଆଡ଼େ ପୋକ ପଳେଇ ଆସୁଛନ୍ତି, ସେ ମାଣିଷ ମାରିକି ଖାଉଛନ୍ତି ମୋତେ ସବୁ ଏଗୁଡ଼ାକ ବେକାର। ହେ କୁଆଡ଼େ ଆସିଲା ରେ, ଏ ତେରିକା, ଯା ଯା। ଆରେ କାହିଁକି ମୋ ମୁହଁରେ ବନ୍ଦ କରିନି ରେ, ଶୁଭୁଥିବ ପିଲାକୁ।